Hello there, this is an Algebra 2 video. It is Chapter 4, Section 7, and today we will be talking about transformations of quadratic graphs. Now before we can get into the transformation portion, you will recall that we've done transformations for absolute value. It looked a lot like this guy does, where we could shift the graph of the absolute value function left, right, up, or down, and that's eventually what we want to get to excuse me, with quadratic graphs. But first we have to talk about vertex form. So vertex form is when you have a quadratic. Now you recall that standard form is ax squared plus bx plus c. It's what we used for the quadratic formula and all that kind of good stuff. But now we have a different form, and this is not ax squared plus bx plus c. I will tell you that the a value here is the same for both forms, and just so that we can be clear, this is the standard form over here. But there's no b or c in this expression, but the a's in both forms are the same a. So just so that you know. So when you have an equation in vertex form, a quadratic equation in vertex form, there are some things that you need to know about the letters. The vertex, we know that with standard form, the vertex is x equals negative b over 2a. And then you have to plug the x coordinate into the equation to find the y value. That's actually a lot more time consuming than if you had it in vertex form. So when you have it in vertex form, then the vertex is always hk, and it's important for you to note that this is a negative h, but this is positive h. So they're always the opposite. So if this said x minus 3, the vertex would be positive 3. If this said x plus 5, then the vertex would be negative 5. The k value, however, stays the same. So if this is a plus k, and this is a plus k, if that's a minus k, this is a minus k. So there's your vertex. The axis of symmetry, just like it was before, is always the x coordinate of the vertex. Since that's h, then the equation would be x equals h. And then the a does two things for us. It determines the shape of the parabola, and we'll get to that a little bit later. Basically, it determines whether the parabola is really skinny or a little bit fatter or wider. But also, it tells us the direction in which it opens. If the a value is positive, it opens up. If the a value is negative, it would open down. But again, we will get to that in a few minutes when we get to some further examples. Okay, so first, before we can even start talking about graphing the quadratics or transforming them, we have to figure out a way to transform or to convert, if you will, from standard form to vertex form. So this is your standard form, and we want to put it in vertex form. Well, that requires that you do a completing the square. Okay? But I'm going to show you two different ways to do this, and then you can choose the method that is easiest for you. If you're really comfortable with completing the square, then go ahead and complete the square. But completing the square in this case is a little different than what we've been doing, because in the past you always had a number on the other side of the equal sign. It was like x squared plus x, 6x minus 5 equals 0, and now it's not. So you can't add something to both sides. So I'm going to show you how to get around that problem. But basically the first step is to take the middle term and divide by 2, which is 3, and then we square that result, which gives us 9. Remember that we always circle this guy because he's pretty important. So you get 9. So now we have y equals x squared plus 6x. We're going to leave our blank like normal, but instead of adding the 5 to the other side, we're just going to scoot him down a little bit. He's just going to be down there. So it's still minus 5. We haven't moved it to the other side. The other part of this, dividing by 2, squaring, is the same as before, and we're going to add 9. Now in the past, we added 9 to both sides of the equation because we wanted to keep both sides balanced. But now I can't add anything over here because I can't add 9 and y together. A variable and a number just isn't going to work. So I can't do that to keep it balanced. The only other thing I can do to keep it balanced, which sounds kind of weird, is to add the 9 and subtract the 9 from the same side. So really, I haven't, it's like I said, I'm going to give you 10 bucks, I'm going to take 10 bucks from you. I didn't do anything. I didn't give you anything. So I'm adding 9 and subtracting 9 at the same time. Now, I focus just on this portion of it, and that's the portion that I do like I had before, which is where I factor it, right? So I'm going to write y equals x, and of course this number before you squared it is always what goes in your factor form. And then -5 minus 9 is -14. So believe it or not, excuse me, that is your vertex form. Sorry, I was losing my train of thought there. That is your vertex form. I need to get on the right page of my textbook. Sorry, for some reason I'm on the wrong page. Alrighty. So now I want to show you how to do it the easier way, I guess, if you will. I don't know if it's easier for you. This to me is pretty easy, but some people have a hard time with it, so I do want to give you another way of doing it. You will recall, hopefully, from before, that we can find the vertex ourselves. The vertex is x equals -b, so in this case it would be -6 divided by 2 times a, which is 1. So you would get -6 divided by 2, which is -3. Notice that this is already in vertex form, so my vertex here is -3, because if this is a +3, then the vertex is -3, as I said earlier, and the y-coordinate is -14. That's k, hk. So there's my vertex. So all I'm doing over here is I'm basically finding the vertex the good old-fashioned way, the way that we had done it before. So now to get the y-coordinate, I have to plug -3 into this equation. So luckily we're going to go -3 squared is +9. 6 times -3 is -18 minus 5. So 9 minus 18 is -9, which is the same -9 we had here earlier, and then minus 5. So you're still going to get -14. So we get the same vertex doing it this way or doing it the vertex way. That's supposed to happen. Also, we already know that a equals 1 because I told you earlier that in both forms they have the same value for a. So if this is 1x squared, then in the vertex form there is no number in front of the parentheses, so we assume it's a 1. So we have the same thing. So now you would know y equals, and you just plug in the vertex, x. Since the vertex here is -3, this becomes +3 minus 14, and you get the same exact answer doing it this way as we did completing the square. So just want to give you 2 options for how to get it into vertex form. I'm going to erase this other way because I don't have enough space on my board, but again, if you missed that, you can always go back and rewind. But I need to keep my board somewhat clear. So now we're going to try B, and the difference between B and A is that this guy does have a number in front of x squared as opposed to the first one. So this is going to be a little bit trickier, but like I said, it's still doable. So we're going to go y equals -2x squared plus 8x, and we're going to put our blank, and we're not going to add the 3 together, so I'm just going to move them over like that. Okay? The next thing that we have to do in this case is that we have to factor out the -2, because as I said before, we know that a is -2 here, which means it's also going to have to be -2 in our vertex form. So we're going to get y equals -2, and then you just factor the -2 out. So I know that -2 times x squared is -2x squared, and here I'll need a -4x because -2 times -4 is +8x. We don't have anything in our blank yet, and we're not going to factor the -3. We kind of moved him aside, so right now we're only factoring out of these 3 terms. So we're going to put our parentheses only around these 3 terms, and the -2 is only going to affect these 3 terms. Okay, so now we take a look at just this portion We're not looking at the -2 right now. So right now for this quadratic, A is 1, B is -4, and we're trying to figure out what C is. So we take -b, sorry, that's not what we're doing. I'm confusing the two methods here. I'm trying to get my undo button here. Oh, let's just use the eraser. What we do is we take B, which in this case is -4, divided by 2, which gives us -2. We circle that little guy, we square it, and we get +4. Okay, so my factored form is going to definitely have x minus 2 quantity squared. And because A is -2 here, we're going to have a -2. Y is there. And what we need to do is take our 4 and put it in here. And just like we did before, we have to, instead of adding it to both sides, we have to add it and subtract it from the same side. So I'm going to put a +4 here and a +4 here. But the other part that you have to keep in mind in this case is that this -2 is being multiplied by the 4 as well, because the 4 is inside the parentheses. So because I'm timesing the +4 by -2, I also need to times the -4. And I'm sorry, I didn't do that correctly there. I added 4, I need to subtract 4 from both sides. And then because of this -2, I need to times it by -2. So in other words, because this is a 4 times -2, what I'm really doing here is I'm subtracting 8, because 4 times -2 is -8. So I'm actually subtracting 8, and now I need to add 8. So -4 times -2 is +8, so that's why I have to do it that way. So again, after everything's all the same, I add the 4 in there, and because this number is -2, I still added 4 and subtracted 4, but then I times it by -2 because of the -2 that's out here. So now I have to kind of simplify this value here. I've got -3 plus 8, and 8 minus 3 is 5. So +5, and this is my vertex form. Okay, so my vertex would be +2, because it's always the opposite inside the parentheses. But my k value stays whatever it is, so +5. So my vertex is 2, 5. Now again, if you wanted to do this with the other method, you could. The vertex, I'm going to do really quickly here. The vertex would equal -b, so you would get -8 divided by 2 times -2, because A is -2, and you would get -8 divided by -4, and negative divided by negative is positive, 8 divided by 4 is 2, and you'd get the same 2 value there. Then you would take the 2 and you'd plug it into this, and you'd say -2 times +4, because 2 squared would be 4, and then 8 times 2 would be 16, and -3. So -2 times 4 is -8, and then plus 16 minus 3, and you would still get +5. Once you know what the vertex is, you already know what the A value is, so all you have to do is plug it in. Y equals A, which is -2, plug in your vertex, and you'd be done. So I will allow you to do either method, whether you want to do, let me erase this so my board is clean here. Okay, you can do either method that you want, either finding the vertex first using the b over 2a, negative b over 2a thing, or completing the square. Either option, whichever one is easiest for you, or whichever one you understand better. So now, look at that. I guess I had left a slide here to be able to show you how to do it the other way, but I already did that, so we're going to skip this slide here. But now you can do the do-it-yourself question. Again, you can put it in vertex form either by completing the square or by doing it the old-fashioned way with negative b over 2a. All right, so after we've done that, now we're going to try to go backwards. Now we have a graph that's being shown to us, and it says, what is the equation of the function shown in the graph? So all we have to be able to do in this case is know what the vertex is, which we can see from this graph that the vertex is 3, 2. and we need the a value. Okay, we don't know the a value because we don't have an equation. But we know that it has to be y equals a times x. And since this is a positive 3, this needs to be a negative 3. And this is a plus 2, this is going to be a plus 2. Okay, so that's pretty much the bones of what our equation is going to look like. But now we have to figure out what the a value is because we can't have that a in there. And for that, we have this additional point that they've given us. We know that when x is negative 1, y is negative 2. So what we're going to do is we're going to plug in those values for x and y and solve for a. So we're just going to plug in negative 2 for the y value. We don't know what a is, but x is negative 1. Then we have minus 3 squared plus 2, and all we have to do is solve for, excuse me, for a. So the first thing we want to do is negative 1 minus 3 is negative 4. And there's still an a there. We can even subtract this 2 over there. Be careful that negative 2 minus 2 is not 0. Negative 2 minus 2 is negative 4. And then here we have negative 4 squared, which is positive 16. So this is 16a, and then that canceled. When we divide by 16, a will equal negative, and 4 goes into 4 once, and 4 goes into 16 4 times. So you get an a value of negative 1/4. So now I can go back and put that into my a here, and so my final answer will be y equals negative 1/4 times x minus 3 squared plus 2. This will be my equation of the function. All righty. So now you can try this. I was going to change the screen. You can try this, do yourself number 2. In case you can't read it correctly, this is an additional point is negative 4, 13, and the vertex down here is negative 1, negative 2. Okay, so now that we've done all that, we can finally get to the good stuff, and this is going to be, after we show you all this is going to be our last example. You do want to make sure you have all of this written down in your notes, but basically these are the 4 different types of transformations that we have. We have a horizontal translation, vertical translation, a reflection, and dilation. And each letter of the vertex form helps us determine where we're going to go with all of these translations. So, first of all, we have the horizontal translation, and that is determined by the letter H in the vertex form. And so basically, if you have a plus H in the parentheses, then that means that you're going to go H units to the left, and so that's their color coordinated here. The black graph represents the parent graph, the original graph, and when you move it to the left, it's going to be the exact same graph, just shifted however many units H is to the left. If you have a minus H inside the parentheses, then you're going to shift it to the right. We also have a vertical translation, and in a vertical translation, again, the black graph represents the original. If you have a plus K, then you're going to go K units up, so that one went up. And if you have a negative K, you're going to go K units down. And that's how you're going to translate the graph in that way, either horizontally or vertically. Then we have our A value. Our A value is actually in charge of 2 different types of translations or transformations. The first is a reflection. We kind of already mentioned that before. If the A value is greater than 0, then the parabola is going to open up. If it's negative, it's going to open down. Okay, we already kind of knew that. And then we have the last one, which is what we call a dilation. Basically, when you stretch or shrink it. You heard me say earlier that it was going to be skinnier or fatter. That's basically what our dilation is. It's also determined by the letter A. Again, the black graph is the original one, and so you can see that the blue graph is narrower or tighter, closer to the y-axis, if you will. Just imagine if you were pulling the graph up, it would get skinnier. Or if you were compressing it, imagine it going between 2 plates that are compressing it, then it would basically like make it go flatter. So that's why the red part is the compression. So basically we have A. Now we're not talking about whether it's positive or negative here, so because the absolute value of A is bigger than 1. So if you have 2x squared or 3x squared, 5x squared, all those numbers greater than 1, then you're going to have a vertical stretch, or it's going to be narrower. If the a value is between 0 and 1, so it's not going to be bigger than 1, it could be like 1/2 or 1/4, like we saw in the previous example, 1/3, 2/3. Anything that's between 0 and 1, you're going to have a compression, so it's going to be wider. All right, so you need to know all that stuff because we are now going to use that to graph this example. Now, in your do-it-yourself question, you're actually going to be, it's going to be a little bit easier because your do-it-yourself questions are already in vertex form, which makes it really nice to be able to graph. In my case, I have to put it in vertex form before I can actually try to graph it. So I'm going to use the completing the square method because I want you to just be able to see that one more time. So we are going to factor out the 4 from the first two terms. And then scoop the 40 over. So 4 times x squared is 4x squared, 4 times -4 is -16. And then I'm going to do my thing, which is to take the -4 divided by 2, which is -2, square that, which gives me a +4. I'm going to add 4 into my blank, and then subtract 4 from the same side. And since there's a times 4 here, I'm going to times this by 4 as well. So then I'm going to write it in my factored form. Y equals 4 times x minus 2 squared minus 40 minus 16, which is basically minus 56. So my vertex is going to be not -2 but +2. I don't know why I put those dots there. +2, -56. My axis of symmetry will be x equals 2. And there we go. So the only part about this is that we want to see is, as far as the transformation, we have a horizontal shift. So normally the graph is going to be at 0, 0. But this graph is going to be shifted 2 units because this is a -2. It's going to be shifted 2 units to the right. So you can see that I put here that if it's a -h, you're going to go to the right. And if it's a +k or a -k, it's going to go down. So I have a -k, it's going to go down. -2 is going to go to the right. So I'm going by 2's here, 2, 4, 6, 8, 10. So here's my -2, it's going to go 2 units to the right. And -56, that's -50, I'm going by 10, 20, 30, 40, 50. So -56 is going to be right about, if that's -60, maybe right about here. Okay, and because my a value is a +4, the +4 tells me it's going to open up, but also the 4 is bigger than 1, so it's going to be a very skinny graph. So at this point, I have no means to actually figure out what the next point is. So once you figure all that out, I have to figure out what at least one other point is. So I'm going to go ahead and pick, this is 2. So I'm going to go ahead and pick x equals 4. What would happen to my graph if x equals 4? I basically just want to find a point. I already know that I have x is 2 and y is -56 because that's the vertex. So you remember how we used to do tables. And so I can pick 0, 2, and 4. And I already told you how much I love plugging in 0. These points are equidistant from the 2. So when I plug in 0 to my equation, I'm going to get 0 minus 2 is -2, and -2 squared is going to be +4, and 4 times 4 is 16, and 16 minus 56 is going to be -40. So these are both going to be -40. Okay, so to get that additional point, I'm going to go 0, and I'm going to go 10, 20, 30, 40. And also at 4, it's going to be 40. And then your graph is going to be very skinny compared to the normal graph. And that is how you graph But again, once it's in vertex form, and in your case, they're already in vertex form, so you'll have less work to do than I did. But once you have completed these examples, you will have completed your notes for this lesson, and I will see you in class, and thank you for watching.